Hi, today we'll be talking about axonal transport or exoplasmic flow or exoplasmic transportation, in short AXT. This is a non-impulse based conduction through the core of the fibre, a flow through the core of the fibre of proteins, both from the central system towards the terminals of the axons. This is antegrade flow, and from the terminals back to the central system, which is retrograde flow. It transports a number of different structures, including brain growth substances, axonal growth, nerve growth substances, enzymes for regeneration and repair of nerve fibers, metabolites coming back on the retrograde flow, and so on. More important for us, though, is that it transports through the antegrade flow rapidly synaptic vesicles to replace those that have been lost during a synaptic exchange of nerve conduction. And also trophic factors to the end organs that maintains trophic nutrition to these organs, ligaments, muscles, bone, tendons, fascia, and so on. The process is actually produced not by pressure as such from one end or the other, but from kinetic proteins. These move the substances up and down the nerve fibre, and so there's no pressure build up in the nerve fibre as such. It's not like water being pushed down. These kinetic proteins travel in microtubules and carry, which is called a cargo, carry these substances up and down the axon. So don't think of this as a pressure forcing this stuff up and down. The loss of this flow, the compromise of this flow, can result in a number of things, including degeneration effects in the axon. Central nervous system defects is thought to be partly, at least, responsible for Alzheimer's, Parkinson's, Murray-tooth disease, and so on. So it's vital to the health of the nervous system. For our purposes, though, it's the two functions it has in maintaining synaptic exchange and also trophically nourishing the end organs. Now, without these factors, you'll get fatigable weakness. And this is detectable during the physical exam. So you'll find this weakness, and it'll be distributed according to what's blocked. So if the flow is blocked at the spinal nerve or nerve root, you'll find that weakness distributed in a segmental pattern. If it's occurring in a nerve, then it may turn out to be a total neuropathy. I mean, total in the fact that the distribution may be total, or it may be an end part of that nerve. So the distribution is variable. Also, this flow is more susceptible to disruption than is the electrical flow, quite a lot more susceptible to disruption. So don't expect to find other factors that you might find with a radiculopathy or neuropathy, such as sensory loss, reflex changes, or even Tinel's test. This sensitivity to compression, traction, torsion, shear, and so on means that you can have quite minor factors causing this disruption. And this can evidence itself as a multi-crest syndrome. So you'll get a block, say, at the spinal nerve root, which isn't by itself enough to cause clinical changes. But another block, say, at the elbow, may produce changes from the elbow downwards. So these multi-crest syndromes will be seen distal to the distal block. Okay, in a nutshell, that's it. I'm going to put a mind map up, and we can discuss this in more detail on that mind map.